Hello, I am the Ronan Pawn, and welcome to twitch.tv/Ronan Pawn livestream on twitch.tv/Ronan Pawn. What day is it? Anybody have any idea? What day? It's a Sunday, and it's a November 15th, and it's a 2020, and it's a 3:14 p.m. in the Eastern Time Zone. Goodness. Well, that's your daily time report live stream. Thanks for tuning in. We'll be back on the 9s with the weather and traffic. Welcome to the show, nobody that's here yet. I don't blame you, it's another Python stream. This is 3 in a row. 3 in a row, but I promise you this is the last one in a row. This is the last one, yeah, because I've hit a place. I've gotten there. We did 2 live streams because I had a couple of theories about what I could do with my cluster truck speed run. It's not specifically for cluster truck. My speed running, live splitting, auto video analyzing thing that I wrote. Had a couple ideas, and we tested them here on stream live. Found out most of them were shit, didn't work. It ran into some slight issues hither and thither. I'm just checking, just having a look around here, making sure that all of the things are working on the stream. Give me a second. Just give me a damn sec. I just need a second. How about a second, huh? Yeah, that looks good. Yeah. Yeah, that looks... Just checking, because, you know, nobody's saying hi in chat. Making sure that the notices are going out. Man, it is a windy day here in Detroit. Entirely possible that we'll just suddenly go offline, either because the internet done went out or the electricity done went out. Had a little blip of the electricity cutting out, I don't know, 15 minutes ago. Not 15 minutes, like an hour ago or so, right in the middle of me coding. Thank God I use PyCharm, which is one of these things that just updates as you go. So there's no, oh shit, did I save it? It's always saved. Notepad++ style, baby. Linux for life, except for I don't use Linux. Hello, Mosaic Task Force. Welcome to the first 4 minutes of the stream, apparently. Yeah, but... yeah. Welcome to the show. The big show. The show that's about Python and coding and whatnot. So yeah, we've done... this is the 3rd live stream in a row where I did coding instead of anything entertaining. You're welcome. First live stream, what were we doing then? It was like I was theorizing on something. Was it the search methods? Was it I had an idea about how to make the search testing go faster. And then we played with that idea, and then I figured out, oh my god, it didn't work out at all in the first live stream that we did. But we tried it, we were like, ah shit, there's some reason it's still getting hung up. And it just didn't improve times that much. It improved them a little bit, but not much at all, by about 1 second of our 2-minute test video. And then what? And then the next day, I realized, in fact, just about 20 minutes after the live stream ended, I realized that what I had just done to make it a little bit faster could be increased by 13 times. And then I did that. We found out that... that's not why it takes as long as it does. And that, yes, technically you've made these things faster, but they are blocked by other processes that are much slower, and so you can't beat that little bit of a glass ceiling bottleneck kind of scenario there. And so I came back and we integrated that, and by the end of that live stream, we'd figured out how to make this thing not quite twice as fast, but a fair bit speedier. 1.7 times as fast as it was before, I suppose, and it really came down to turning off the GUI. The drawing to the screen, the updating the user interface, that was slowing everything down. And then, at the end of that live stream, we were talking about multiprocessing. That really the only way that we were going to beat this beast was with multiprocessing. And so, ladies and gentlemen, boys and girls, today I give you multiprocessing. But not yet. We're waiting for people to show up. Hello, Mosaic Task Force. Looking forward to hearing how you improved it with a factor of 3. Then you learned to do profiling. Yeah, and then I learned to do profile. That also happened in that stream. And then, when I did the multiprocessing thing, found out you can't do profiling on a multiprocess thing in Python. Son of a bitch. But what are you going to do? So yeah, the big bottleneck, the big glass ceiling. Oh, Jesus, I'm spinning. The big bottleneck, the big glass ceiling comes down to, listen, what we're doing in SplitRP is we're bringing in a video file, right? And that video file is compressed, encoded, encrypted, RSA, and it's not encrypted. But you know, it's MP4 is what we've been analyzing, and it can support a number of other different video files here. OpenCV just kind of handles that end of things. But there's going to be a minimum time that it takes to decode a single frame of an MP4 video encoded in H.264, H.265, you know, that sort of a thing. It's going to take some time. And that is the glass ceiling. Is we can do as many tests as we want in the time between frames, but it's going to take a second to upload a frame or to decode a frame. Jermaine says, switch programming languages? Just kidding. Yeah, no, Python's doing pretty okay for me. And I don't think a different programming language would necessarily decode the video fast. Maybe it would. Slightly, though. We'd be talking about a slight gain. But yeah, that's the big overhead, and there's really no way to beat that. You know, you got to access the file, and then you got to have an I.O. channel open with that file. You got to talk to that file. You got to say, hey, I need a frame of video. And then the file's got to, like, decode the frame of video, decrypt it on RSA, 3 hash the file with the... It's got to decode it, and it's got to hand it back to you before you can do anything. And you know, there's no way to defeat that. Unless you had 12 concurrent processes all accessing 12 different locations in the file and pulling the data in that way, then you could do it a little bit faster, couldn't you? Yeah, so that's what I did. That's what I did, and that's what we're going to have a look at today. Come break the glass ceiling by becoming a female vice president. Others make speedrunning moderation tools. Some break the glass. I see. But yeah, that's what I've done, and I've cleaned my code and everything. You know, I worked on it yesterday. I got to the point. I worked on it the day before and yesterday, and I got to the point today where it's all clean, it's nice, and it's ready to, for example, throw up to GitHub in a new branch here, video moderation tool branch. So SplitRP, this particular version of the code, not a compiled version. You can't download it and run it like an exe. I'm not doing that yet. It ain't ready for that. But the code itself is available today at github.com/RonanPawn/SplitRP. Just navigate your way over to the video moderation tool branch and pull this shit up. And under this shit, you'll find the new README file that I typed up just before the live stream here. It's showing at you, and it'll claim things like SplitRP now uses multiprocessing to conduct video analysis 3 times faster than any previous build, consumes only about 1.5 gigs of memory, while processing 1080p video. I should have put in memory. While processing 1080p video, and so less when it's not 1080p, when it's 720. Process about 4.5 seconds of 1080p 60 frame per second video per second, which is pretty fucking good. 8.5 seconds of 1080-30, 12.5 seconds of 720-60, and 15.5 seconds per second of 720-30 video. I can do our test file, 2-minute and some second long test file that I've just been using for all of my benchmarking, which is a 720p 30 video, 2-minute long video done in 8 seconds. 8.4 max. Probably more like 8.2. I have a headache. I am not 100% today. My English and typing suffer when my brain is in pain. Just your brain is in pain? I'm insane in the membrane. Insane in the brain. But yeah, I was, we've got this sub goal here that I need to update. You guys hit the sub goal. We're going to do some cluster truck, some Twitch percent, some speed running. I just wasn't feeling like it. And I was like, well, I guess I could just not live stream, wait till tomorrow, or we could have a review day on Python multiprocessing. So that's what I'd like to do. I'm surprised that so far it's just Germacian Mosaic Task Force, participating in chat. Usually for my live, even my coding lives, there's been certain people who are like here with bells on, like, shit, he's doing coding. So I'm surprised that there aren't that many. Did the notifications not go out, YouTube, Twitch? What are we doing? What are we doing, people? I hate to jump in You know, I'll tell you what, we'll jump in at the beginning again. Every live stream I do this just sort of to eat time and let people show up, so I'm not having to say the same thing again twice, or more so, because, you know, I care that that the people who want to see it get a chance to see it. So we'll start from the beginning. And the beginning was kind of here. I had the theory of how to increase the performance on my testing. So ultimately what SplitRP is doing is going through a video file, and it's got images stored that you given it PNGs, you put them in a directory, you tell it, if you see this, I want you to do that thing. And that's all, you know, that's all it's doing in a very complicated and convoluted and difficult to work with way. But it's going through all those images and seeing, should I split? Should I pause? What would happen here if I were timing a speed run directly from a video file? So, you know, we want those tests of comparing two images to be very, very quick. And the method that I was using was this simple composite method where we take an absolute difference between the two images. We sort of layer both images over each other and subtract them and take off all of the negative signs. And we get ourselves basically an image that, if we drew it out, would look like an image just of the differences between the two images. And then we add up all the pixel data in there, and then we divide that by what the maximum pixel data value could possibly be in order to get ourselves a percentage of how similar one image is to the other. How similar are these two images to one another? And so then we give it a threshold, which we do in clustertruck.rp. Under the tests here, match 95%, unmatch 100%. Simple as that. We tell it, this is the image that I want you to look at, and I want you to compare it against what's on screen or what you got in memory there, and then if it's a 95% or better match, then consider that a match. And then we've got little characteristics down here to help us like optimize and reduce the area that we're scanning, as well as limit the area that we're scanning so that we get more direct hits, more true hits and less false hits. We look at a smaller area, we know exactly what it's supposed to look at. If it matches, it's a match. Knew a guy with a sub, but then he murdered someone in it and it was melted down. Otherwise, he could have given you a sub. That's okay, I got 111 of them. You know, I'm thinking of attacking Britain by water. Milgrips, hey Paul, hey chat, awesome seeing you tonight. Thrilled for the rocket launch of my code. I mean, it is very fast. I don't know if I'd say it's rocket-like, but sure. They're launching a rocket in this weather in Detroit. It's just the wind speeds of 752 kilometers per second. There's a lot of wind blowing around. We might lose. We could lose broadcast at any moment now. The internet, the electricity, the roof could come off. Because, you know, there's. I'm sorry. I'm just still upset ever since my sister died. That house fell on her. It's a really deep Wizard of Oz reference. Doesn't really make sense. Kind of reaching. I'm doing that a lot lately. Just reaching. But hey, that's what we're doing a lot lately. So yeah, this is the absolute difference method. We get a difference of the two images, then we sum it all up, we divide it against a thing, and we come out with a raw percentage. It just tells us how alike these two images are, and then we can decide whether or not they're close enough for government work, whether or not we should call that a match. I came up with an idea that I wanted to test, which was, what if, instead of doing that absolute difference, what if we just took the sum value of the entire image? You know? So without doing any absolute difference subtraction, pulling off, you know, negative signs and that sort of thing, what if we just added up all of the values in the file and saw if the number of, you know, colors, ostensibly, in one file was about the same as the other, and if it was, then hey, we've got a near match, and then we can run the proper absolute difference test, because that one is very accurate, whereas this would be a lot looser. But the idea was, if it's faster, we could do that first and dismiss a bunch of frames that we don't have to do with the more intense search. Turned out, in testing, that Germasian cheered 10. Launch time is like 2 hours from now, 7:27 Eastern. Oh, it's 3:28 Eastern right now. Where are you, Milgrips? In American Eastern Time Zone, that would be 5:27 Eastern. Watch Comcast. Last is this weather, but when it is a beautiful sunny day, the internet goes out multiple times. I see what you're saying there. I decoded it. And yes. In bad weather, it'll stay. The electricity already went down once, but hopefully it holds out. Do you follow Matt Lown and his space news, Milgrips? 4 hours from now, Milgrips is going to start watching some Matt Lown. Is that how it's said? Lown? It looks like with the O and then the E at the end. You want to say Lown, not Loney. Matt Loney! Bite off a big chunk of Matt Loney today. My Matt Loney has a first name. It's M-A-T-T. Sorry, I do have problems converting to Eastern from Central European everyday time. So who? So what? So that was my idea for the summing. We'll just it'll be a looser test, but if it's faster, what we found out was that, in fact, summing takes almost the same amount of time as abstiff. Abstiff is a little bit slower than summing, so it was faster, just not that much faster to do both of them. I went, shit, I guess this doesn't work, this premise. And then I realized that one of the two images that we're always comparing against can be generated ahead of time. Because we load the images in that we're going to compare against. Before we start doing the testing, we could load up the sum value immediately, which means now I'm only doing one sum, which is about the same speed as an abstiff, in comparison to doing an abstiff followed by a sum, so it's literally half the time. Half the time this search can be done. And then I realized that if I wrote the code correctly, there are a number of situations where, for example, we're looking for, let's go down to this one, we're looking for a certain screen where we're going to test 7 or 8 different files against the same image. So we're going to pull one image from the video file, and then we're going to test against all 8 of these videos, or all 8 of these stored files. If we pre-calculated all 8 of those store files, and only calculated the video files sum once, then that means in a list of 8 like this, we would have done 16 tests if we were doing it by the abstiff plus sum method. And we can do that in one test. That is 15 times faster. So we wrote this to test it. This is my little speed testing. No, God, cunting, damn it. With the fuck it, and I can never get a hold of the fuck it. Get down here, God, Jesus, fuck almighty, and then you pull it up, and then... By the way, I do children's parties, so, it's up to there so that you can see as it's coming out. We'll run this little fucking piece of cunt. I do children's parties. So, what we did here was we ran every different version of the test for 3 seconds and counted up how many times that we could do that testing. What we got back was that the absolute different tests could be done 39,000 times in 3 seconds. Some testing, I said it was a little bit faster, 43,000 times. If we had one of those values pre-calculated, then boom, it's twice as fast, 84,000 times we can get that done. And if we had 7, in particular, this was a test of 7. If we had 7 tests and it only took us one sum test to do it, then we could do 545,000 tests in 3 seconds. Boom. Then the problem turned out. Then there was a problem. The problem turned out to be that no matter how fast I make this searching stuff, actually getting at the frames in the video file is the main blocker. That's the main bottleneck. That's the glass ceiling. And there's no real way to defeat that. It takes the minimum amount of time to decode an H.264, H.265 frame. It's always gonna. Unless you did as many CPU cores as you had at once, all doing the same thing. So they're all accessing the same file, but in a different place. And they're all able to do that all at the same time. And that is what we have now. Multiprocessing, ladies and gentlemen. MP test. Very simple little set of instructions and code in order to instantiate multiprocessing in Python. Very difficult to penetrate and very difficult to reduce to a linear, can pickle it. I had to learn the word pickle. I mean, I knew the word pickle from childhood, but not in reference to multiprocessing. Yeah, very difficult to like penetrate what the hell's going on out there. There's so many people that are doing it in a more complicated, convoluted, ridiculous way, and they want to teach you the hardest way in the first place. And I read like, a couple dozen different pages in order to get down to the grassroots on what needs to happen in modern Python to enable multiprocessing, and that's basically it. There ain't much to it. We import multiprocessing as multiproc. That's what I chose to do. But we import the multiprocessing class, and then we check if name equals main, because what we want is this code is only supposed to run in the originating thread. We're going to split as many threads off as we have CPU cores, and I've got 12 of them, virtually 6, but it's virtually 12 of them. So we're going to split off 12 versions of this. We don't want all of them running the same code in loop. We don't want all of them thinking that they're the main program, that kind of a thing. So if name equals main just decides that only the originating thread will run this code, and then identify how many total workers there are. And you don't even have to do this, depending on what you want to do with multiprocessing, but the way that I wanted to use it, I needed to do this. We get the CPU count. So this will return 12 because I got 12 CPUs. I'm just going to save that as total workers. Then we start up a pool, multiproc.pool, which is basically where the multiprocessing happens. It happens in the pool, clothing optional. It's a skinny dip multiprocess at my house anyway. Hello, Carvey Z. How you doing? So you take your code yarn and slit it into multiple threads in order to make moderation rope to hang myself with. I don't know what. And the BMA dev, did you find out if name the hard way? Yeah, I already knew about it because I've looked into this before, but I did run without it for a bit. And what would happen every time I ran it is I'd get 12 UIs to open up. It would spawn the program open 12 times again. I knew that I had to do something with this if name equals main, but I just maybe I don't. But yeah, so you just open up the pool, and then I had to do something a little bit specific that comes up only really in multiprocessing. Well, I don't know. Some people use it. It only comes up in multiprocessing. I had to use this partial thing. For func tools, I'd import partial, because what I want to be able to do here, and what I am doing here, is I want to be able to send a dynamic piece of data, a dynamic argument to the function that I'm calling, but I also want static arguments. So, like if you're going into any given function, like this POI test here, I want to pass across video path, a file path, a start and end, and a worker num. And in fact, this is exactly the one that it's feeding to. I want to hand over a worker num, and the way that I want to do that is by feeding in a dynamic object into pool, or into map, rather. So the mppool.map, and that's going to be the range of total workers, but I want all of this data in front of it, vid path, file path, start, end, and that's going to be the same every time. So using this partial thing, I don't know why, but it just, it works. I can create a sort of a function call that isn't complete yet, that will get stored as part of a function call, I guess, is what partial is doing there. So I'm calling POI test, and the arguments that I'm going to send are vid path, RP path, start, and end. So that takes care of the vid path, file path, start, and end. And then when I actually call the POI func, which is actually calling POI test from within it, then we get POI func, vid path, RP path, start, end, and then total workers, which, because it's a range, is going to be between 0 and 12, and it'll call one of them with 0, and one of them with 1, and one of them with 2, and up to 12. So that was a little piece of like, how the fuck am I supposed to do this that I had to go out and find? But I did that, and that's pretty much it. Boom, I opened a multiprocessing thing. It's going to run everything that goes on in the POI test. I close it when I'm done. I join it when I'm done. And then I can process the data that it's handing back. And this in particular was my way, and maybe there's a better way of it, but it was my way of solving the the issue of each one of the lists is going to hand me back data. They're all going to be formatted the same, and it's basically going to merge all that data into one version of it when it hands me back this POI list when it comes out of the multiprocessing thing. What's going to happen is I'm going to end up with data that's stored, each one of them will have their own package. So it'll be one long array. and there will be 1, 2, 3, 4, there will be 12 different array chunks in which is the data that each of them put into the array, is the data that I actually want. I want that data in a list, and an ordered list in particular. Well, and I want all the arrays like just one after the other, not embedded into a 12 and then below that. So I did this little bit of Pythonic, one-line for testing stuff. I can't remember what they call this, but this is one of the reasons why I love Python. This is actually borrowed from someone else online too. I was looking up, how am I supposed to get the data back out? And this was the coolest implementation, but I do love doing this whenever this one doesn't make sense to me. But J for sub in POI list for J in sub. What it does is it basically, takes one dimension off the array. So all of those different 12 packs of data, they get ripped out of that and put back down in an ordered list where they aren't separated by those 12 returns from 12 different workers. And that gets it done. And that's all what was needed to like call an get a multiprocessing thing going. The problem, however, with multiprocessing isn't so much in instantiating it, it's in making a function that can multiprocess. Because you basically just have to go old school. And I wish somebody just would have said that. Go old school, and you got it. Because I didn't actually find anybody saying it, but I knew just from the concepts of threading and stuff like that I'm familiar with. But you can't hand something that's going to be in a multiprocessing worker thread. You can't hand it an object that everything can touch. Because what do you do then if like the multiprocessing thread tries to change something that's in that thing, and it's each of the pipes is a pipe that it can't get out of. The walls are thick and metal. So if you try and pass in an object that exists outside of it, what's it going to do? It has to either duplicate that object in its current state and put it in each of the pipes, a copy, and then when it gets done with it, what does it do with it? Because now you got all these different objects. Am I supposed to try and merge these back together? They could have been changed in ways, by each different thread, different ways, which value should override the other. So basically, you just got to write old school. You got to go back to linear thinking, forget about you can get it done in classes, but you might as well not. It's just going to be a headache trying to get it to work. Go back to thinking like you're programming in QBasic, man. Basic programming. It's a line. If it needs access to it, it's got to make it. And so that's what I've done in this POI test. This is my worker thread function. So everything that happens in here. We pass in a video path, a file path, the start of where we want to analyze the video file that we've got, the end of where we want to analyze the video file, and then the worker num to tell it which worker it is. First thing that we do is we open up our own input-output stream to the file, to the video file. We don't hand that in, because we want each of them to have their own so that they can operate on it. Next thing we do is with the file path here, we open up our own copy of whatever pattern file we're using for SplitRP, in this case, the clustertruck.rp file. Open up our own version of it. We're not passing objects in. We're not passing copies and duplicates of objects around. We're making our own goddamn version, because that's safe to do anyway. The Light Guy 89, 8 months on an 8-month streak. Welcome back to the Big Dick Club. Thank you so much. Hey, Pawn, how is it going? It's going good. I went and got all multi-processed over here. I am 3 times faster than I ever was before. The manager class is the built-in way to manage thread-safe memory access, is Roundtabler. See? And then you could go learn the manager class. And then you could also do stuff with if you want to build it into a class, you could do stuff where you override the get state and the set state in order to make it so the pickling will just write old school. Fuck it. Just write it old school. Fuck it. Who needs it? Who needs it in your life? Just go back to fucking basics, man. Basic programming. Go back to just linear. I'm not grabbing objects and asking for this and that and I'm not spawning up. No, go basic. Then you don't have to worry about all that shit. Huh? That's what I did. And it's just easy to get into, That's what I would, if I made a video saying how to get into multiprocessing with Python, I'd be just write simple, straightforward code. Make it a fucking discrete function that doesn't pull anything from anything anywhere. You hand it in, and if it needs an object, it fucking spawns that object in, inside of itself. It's one way to go. If you don't have like big data sets that you have to hand around, Only useful if you don't need to mutate data. Oh, God. See, there's too many considerations. So, we spawn up our own video object. We spawn up our own clustertruck.rp file access object that I wrote in file handling. And then we start doing math. The worker, this is how simple I went. The worker's I'm not going to tell the worker what to do. I'm going to tell the worker what everybody's doing, and then it can figure out what it's supposed to be doing when it goes to initialize. So it calculates what are the total frames. So we've got the end minus the start to figure out how many frames there are that are going to be processed by everyone, not just this worker. And then it says, well, how many workers are there again? And it pulls that multi-proc CPU count, a value that I could have handed in, but fuck it, we're going to do it right here. Frames per worker. We need to figure out how many frames each worker is going to have. And we do that by taking the floor of the total frames divided by the total workers. So in my system, there's 12 total workers. We got total frames. We just take the floor of that. So the integer that's lower, if it's a .9, then it's a 0. You get me? You get me. Then we set the new start. Okay, we had a start when we started. Now we got our start. What's our start? Our start is equal to start, the original start, plus our worker number times the frames per worker. So each worker is figuring this out. Each worker is doing this unnecessary math, but fuck it, it's easy, so do it. So he figures out where he's going to start by doing, if this is 0, because you can be worker number 0, then it's 0 times the frames per worker plus start. And that gets you the start value. If it's 1 times, then it's start plus start. You see how that works out? See how that works out? Because of the 0 value, you got to do start plus the start times the thing. See? Or else two of them would start at 0, and then one of them wouldn't even do the other half. And then we also decide what end is going to be. And end is simply equal to whatever our start is that we just determined, plus the number of frames per worker. Boom! Now every worker has calculated independently and individually what its job is for the day. We didn't tell each worker what to do. I could have formatted those values, had a bunch of fucking arguments in this line telling it, here's where your start is, your end is, fuck it. Fuck, you calculate it. I just gave you a whole fucking CPU core, bitch. You calculate it. That's what you just ask old Jack Burton what to do when the pillars of heaven quake and the storm, the lightning comes cracking down. Sounds complicated and simple. Exactly. What if the workers want a higher salary? What about paid lunch breaks? Well, then we just cut them off. We shut them down. We pull the plug. Or DTE, the wind blows and knocks out the power for a brief second while I'm doing a test, which happened earlier. What about overtime? I don't really get out to the bars anymore. Certainly not that grill. I spent a lot of time at overtime, dancing and... Oh, you mean, no. After hours, paid, time and a half? Fuck that. We don't employ anyone. Nobody gets to work more than 28 hours, or else we got to pay them health insurance in America. Thank God Obama left that big fucking loophole. Yeah! And Joe Biden ain't gonna do shit about it. Hooray! Anyway, if file... So there, the worker has just figured out what his job is for the day, and he did it all by himself. Pat him on the head. And then if file.rescale values is none, so this is now we're accessing the information that is stored in clustertruck.rp. At the top, we got things like translate and rescale that allow us to do tricky shit, where somebody recorded their gameplay and then, scaled it and shrunk it and stuck it in a corner, but it's still at the right resolution. We can tell it we can tell it where it is and how to read it with these two values here. So we got to check for that when we're running through this. And we got to reprocess this file. We could have processed this file on the outside, maybe been able to make a duplicate of an object and then hand it in raw somehow. I don't want to learn how to do that with multiprocessing. Fuck it, we'll generate it here. So we generate the file. and we do all of the things that need to be done for potentially converting different file spaces. The pattern files, values, tests, images are conformed to the video properties. So that's what needs to happen here. We use the values from the video against the values that are in the file, and we try and make them conform. As long as they're both in the same aspect ratio, it should work out. So we do all those things. That's all that's going on here. We pull out what the resolution is by grabbing the frame width and the frame height from the video. Maybe we use the rescale values if they exist in the clustercheck.rp file. We convert some shit. We convert if we add the resolution in the convert process because all of our tests are written at 1080p. If we've got a 720p value, then it can just scale it down to that size. We tell it the resolution and it figures out whatever conversions need to do. Then we initialize our packs, which builds the image files and does a bunch of pre-calculation on them so we don't have to do them while we're doing the tests and shit. And then we add translation to it again for the weird situation of people moving the file around or moving the video feed around in the video feed. And then there's a crop set and blah, blah, blah. And then we get to, almost getting started. We've set the read-write head, it's not a write head, but the read head for the video onto the frame on which we are going to start. And then we set up some initializing variables that are going to they need to be, and then you set them and then you open them and then it's good. And then we start getting to work here. Process all frames assigned to the worker. Well, the current frame is less than the end. Do these things. A couple of more initialized variables there. We read from that. We positioned the file head before, but we hadn't read from it. We read from it, and that gets us our first frame, and it also gets us a Boolean value that we never use that tells us whether or not there was a frame there in the first place. But it gets us our frame. And then we crop that frame down to the master crop size, which is also established in clustercheck.rp here, screenshot area. So we crop that down, and then we convert it to the correct color space for analysis. And that's done because of different things between OpenCV and NumPy, and they assume that it's going to be this and that and the other. So we just convert it all to the same color space. Takes time. Takes time to do that. Maybe there's an iteration, there's a version of this where I don't bother doing that. But for now, I do that. And then we get to actually get started. We're running our tests now. Remember the tests that we went through in speed testing? We're about to find them right here in the code. For test name and file tests, every test that's in the tests, we're going to test the tests. What? Yeah. So we open the test, which is equal to file.test test name, obviously. And then we check. This is a very important part of our testing right here. Is this little section makes sure that if we've already processed the frame that we're working on from the video in the way that it needs to be processed, then we don't do it again. If we are running one of these tests, like LS Dark that has 1, 2, 3, 4 different images that it's going to be processing against, those are always going to be this size with this color value and this match percent. So the image from the video only ever needs to be processed to those characteristics once for those 4 tests. And that's what happens here, is it makes sure that it does that, but only if it has to do that. By checking to see if the last proc, which we set later so that it carries over across iterations, is the same as the new values coming in, and that saves us time of doing image processing. It also is where we do the shot summing here, which is one of the intensive processes in this test. We take the sum of the 2 files, that we compare how much the sum is and see if they're close to one another, and that gives us a percentage, and that's our way of dismissing a lot of frames without doing the more intensive test. We do that once for all 4 of those files, because we only have to. We only have to process it once, so we can get the sum once, and that means that's immediately 3 times faster than it would be the other way of doing it. So we do those things, then we drop into the proper test. I am tracking how many tests we're doing, just to be impressed by how many tests we are throwing away using this method, and we throw away about 90% of the tests that we conduct doing this much faster version of the test before we get around to the more intense version of the test. So this is the actual test right here. Similarity equal to 100 times 1 minus the absolute of the shot sum minus the image sum divided by max. And yeah, the shot sum's already been calculated. It's an int. It's an MP shot. That shot. Why don't I just take the absolute up there? I mean, it doesn't really make that big of a difference, but why not just do it there? It's one less calculation that you need to run. Do the absolute there. Oh, but it's the absolute of one minus the other. That's why, you silly boy. Right. So we take shot sum minus image sum, and we take the absolute of it. One of the little things that I did in order to optimize this even further is I came up with a max value. You'll notice that when we're unpacking what's in test.images now, we've got image sum, and we've got max. And that max value is adding up and multiplying up how deep the pixel data could possibly be. If you had maximum pixel data in every pixel position, what would the maximum be? And then I don't have to do those calculations here. It made this long, so it used to be a long formula. And I'm like, why am I doing that here when I could just pre-do that? So I pre-did it, and now it's done. So we do the first test. It's the sum test. This is 2 times faster than the difference test. If we get a hit, if similarity is greater than or equal to the test match percent, if we get a hit with that, then we do the difference test, where we combine the 2 images and subtract them from one another, and et cetera, and so on, and we get that similarity. And then if that similarity is still greater than the match percent, then we got ourselves a match. And what we're going to do with that is we're going to write to match tests test name the similarity value. Sorry? Yeah, I don't know what's going on there. So matched tests is an empty dictionary that we spawn on every single frame. Okay? Yes, on every single frame we spawn that. So I'm adding a new value to the dictionary, which is actually putting both of these 2 values that we want to save into the dictionary. We're giving it the name, and we're giving it a value. That's how a dictionary works. It's not like an array where you access it by its position. You access it by a name. I think you can access it by its position, but how would you know what position it is in if you just threw shit in there? You know? And I think Python actually supports that now, where you can like very easily de-dictionary it to an array. It doesn't matter. But so that's putting 2 pieces of value in. We wanted to save the test name, and we wanted to save what its similarity value was, so that we have information that we can render out later for logging and those sort of purposes. But that saves all that. And we're storing that to this match test list because we don't want to put that in our final POI list, which is what we're going to return quite yet. Because I've done another ingenious thing that minimizes our memory overhead and also our processing time later by only storing what's important. So we'll carry on here. If we get a match, then we break out of this whole loop because we got a match for this image, and we've stored the similarity and the test name. So we're done with this particular image. We go on to the next image and the next test. And we do test every single test here. It's not... The old way that I was doing this was it would only test for the thing that it was looking for. You know, you start out a video analysis with Cluster Truck, you're looking for the level complete or the level select screen, because that's where every game starts, or the pause screen, and it does look for both. And then, if it drops out of that into the game, now you're running. Now you start the speed run, and now you're looking for the level complete screen. If you find the level complete screen, then you need to look and see if the pause screen comes next. And if it doesn't, and you dropped out to something that you don't know, well, then you're back in the level again. That's how it works. I used to test specifically for the things that we were looking for at that time, but now that we're doing it multiprocessing, we just do every possible test in the file that we can and get all of the data out of it. So we do that test for everything. If we ran this test, and we did the sum test, but it ruled out having to do this test, then I'm adding that up in dismissed, again, just so that I can pat myself on the back for how much time and how much work I'm saving by doing this much faster version of the testing here, and able to compare it. And that's how I get those numbers that we are saving 90% of testing by doing this twice as fast test, more than twice as fast test. Sometimes up to 16 times as fast, in fact. Then we sent the last proc for, being able to not have to reprocess the frame. It's just, if it's carried over, then we won't reprocess it if we're doing the same frame again. But here's where, the genius work of like minimizing how much data we actually store about the run is done. Because we're set up here, if length of match tests, so I'm using that as a Boolean value. If it's 0, if match tests has nothing in it, then that will be considered false. If it's anything other than 0, then it'll be true. So if there's something in match tests and match test is not equal to the last match tests, because we're saving those down here, we're saving a copy of what was in match tests before. So if it's different than what we saw last time, or, it's one of the conditions, or if last match tests is a thing that exists, and match tests is a thing that's empty. So if we've got something in last match test, but there's nothing in match tests, so that's the instance of last frame we had a match, this frame we didn't see shit. In either of those two circumstances, and only in those two circumstances, do we actually save any data about what's going on in the video. At that point, we append in the current frame and the match test to the POI list. And by doing that, I am only recording changes. So if the same tests match sequentially, we don't record it. So if I saw that there was, a level complete screen, and then the next one was a level complete screen, a level complete screen, and a level complete screen, and a level complete screen, I don't note that all of these frames were level complete screens. I note that we saw a level complete screen here, and then it was level complete screens until here. And then I just have two values in memory to store that describe implicitly describe huge chunks of video. Huh? He's a smarty. So that's how we store them, and then and then we release the video, and then we're done with the worker, and he can come home. We do that for every single frame in the video and get all of that information. And it's all packed up into a very tight little description of what happened in the run. And, yeah. Hello, Gnome231. So that's my my multiprocessing worker thread. That's what's done. 12 different workers do it on my system because I got 6, real cores and they virtualize both of them. What's up? We are looking at my video analyzer and I'm about to probably crash my computer or this live stream by running it. It's best case scenario. I expect if I move my hands around, I will freeze completely because this thing now consumes 100% of your processing power while it runs. On all cores, and it just eats it all up. I don't know if there's something that I'm going to need to do to handle that, to be like, could you just consume 94 and leave some overhead on each CPU? Or if I can just let the, operating system and AMD's, whatever they do with their multi-core, just handle it. And it'll make space as it's going. I don't know. But this is going to eat up 100% of all 12 of the CPUs. So if you've overclocked your system, this could stand in for a burn-in test. Make sure to assign real-time priority and assign all cores to SplitRP. Can't you reserve one CPU core for the stream? Suppose it could, actually. I know, then I'd have to know which one it's already assigned to the OBS to. I could say just use 11 cores, but which one is OBS running on right now? And which run is my microphone running on right now? So we're just going to see if everything doesn't crash when we start this thing up. Are we ready to start this thing up? No, let's look at some of the engine before we do, because I had to redo this analyze function, and I had to redo this video function. Look at how tight it is now. Look at how much shit I pulled out. There were so many wires that I was able to just rip out because we're not doing live analysis anymore. We're just doing, video analysis now. Ripped so much stuff out, made it nice and tight. The analyze thing, this was one of those things you got to go to sleep on and come back the next day to try and wrap your head around the logic that's going on here and why it wasn't working, what I needed to do. I ended up just rewriting it basically from scratch. And this gets it done. This is actually where the analysis comes in. So based off of what I was just talking about, we end up, the POI list, we end up with this list that just describes, it should be telling us, at this point in the video, I matched level complete or level select screen and LS dark and LS light. I made these matches. And then over here, I didn't make any match at all. So it'll just say where it made a match for level complete, and that might just be one entry. I made a match for level complete on this frame. And then the next thing that it'll note is that I couldn't match anything on this frame, which means that from here to here, it was all level select screens. So it'll be that, one entry, I saw a level complete screen. I couldn't match anything. I saw a level complete screen. I couldn't match anything. I saw a level complete screen. I couldn't match anything. Now, the way that the clustertruck.rp pattern file works is that you set up, you set up your basic testing here saying the match percentages and everything, but you can establish fairly complicated that give a lot of power to what you can do with these files, patterns and paths for things to take. So at the beginning of a run, we're always looking for the run select screen, and we're looking for level select dark, level select light, and maybe even pause, because these are the three images. These are the three screens from which we know the game can start. So we're looking for the start of the run. These are the three things we should be looking for. And these are tests. If I go up to LS Light, you'll see that LS Light is actually testing 2 different image files for the same match percentage. LS Dark is testing 4 different image files for the same. And then if I found pause, I'm pretty sure it's testing 2 of them. Yeah, it's testing 2 image files. So that's a lot of tests that are being declared just by this little thing. Use LS Dark, LS Light, and pause. And then we tell it what to do under the various circumstances. So if you unmatch, okay? Unmatching, I'll come back to unmatching. It's easier to start with no matching. So no match just means I got to a certain point, I didn't find any match. What do I do? Well, then what you should do is go and start running. And this is running. And in running, we'll be looking for level complete screen. So that's how you can hand things around. You tell it, look for the start screen. These are the 3 things that could be, the start screen. If you find it, then when you cease to find anything, go to running. And when you do that, send the command to start the run. Unmatching allows a little bit more deeper things to be done with this. Unmatching is the concept of when you cease to have a match with what you were looking at here, you could tell it to search immediately for something else so that it will transfer immediately over to a different match. So here, what we do is before I declare a no match scenario and go over to running from run select, we search first for all of those screens that you could start the game on. And then if we're about to no match, if we're about to drop through, first we check the pre-run. And the pre-run is right here. It's going to check for menu dark, menu light, LS dark, LS light. These are the screens where if you're on the level select menu in ClusterTruck, you're about to start the game and you hit escape to go back to a menu up, that's what these are. So this allows me to catch in the video if you were on the edge of starting to run and then you tabbed back, instead of the analysis being wrong by thinking, okay, well, we left that screen, so I guess we're running now, it can detect that no, they went backwards in the menu, so what should it do? It should immediately put itself into looking for the run select again. It went back, okay, then I'll wait until I see the start of the run again. The unmatch concept allows SplitRP to do all kinds of shit that if you were just doing simple match, no match testing, wouldn't be possible. And this is, this is something that could be used for catching cheaters, for finding runs that have been spliced. There's all kinds of power in unmatch, as well as just in the overall system there. But unmatch is a huge part of why time travel is possible. It's the flux capacitor of the whole system. It's not. The unmatch isn't used that often, but it does allow you to do some really fancy things here. So back over to the code and also back over to chat. Normally you can assign processes to specific CPUs. Once they're already initialized, though? Don't I have to close down OBS and then something in the other? Or could I? I don't know. I never really played around with it. I let AMD's techs figure that out for me. I just open things and let the OS run. I would like to at least say goodbye to your computer before you kill it. Goodbye, Poland's computer. I vaguely remember that his PC has a name, but I have forgotten it. Me too. But I remember that. We gave it a name. It's, you know what, it's got a new CPU in it. It's got a whole new life, you know, so we'll have to ask it what it wants its name to be. I know it has a name. I forgot it as well. Yeah, me too. I don't know. I don't remember. Something like Mary or something really like simple like that. I don't think it was Mary, but it must. There's an M involved because that's how my brain works. You know, if I'm thinking Mary, then there was an M. It either started with an M or there's two M's in the middle. I know my brain. But so this analyze function is the thing that enables all of that stuff that I just described with, like, you make a match and then you check for an unmatch. And in the case that there's not an unmatch, then that's a no match. And then it goes over here and it gets it all done in here. I made a little sub function. This would be moved over to UI code eventually, but this just draws lines to the UI. Don't worry about it. We get in and we go through our POI list, which the POI list, I'm calling it POI because it's the points of interest. All of the testing that we do in multi-core is just, it's not doing any logic like we're about to do in this. It's just looking at every single variant of test that we have, running it on every single frame that we have, and then like pointing at something if there's something, you know, that we need to look at when we run this analysis. So we go through whatever frames and tests are in the POI list, and we do this little dance. First, we start out, what cycle are we in? Are we matching or are we unmatching? Or rather, matching or no, you know, or it is matching or unmatching. Are we looking to find something, or did we already find something and we're waiting until we don't see it anymore? So this is when it's true, that means we're looking for something. We're trying to find a match. And if we have a match, which is Boolean length tests, it's if there's something in tests, okay, if we're in the match cycle and we have a match of one of the tests that was noted by our previous, you know, multi-process testing, then we start looking at this. For match test in self.currentPack match tests, so for the tests that are listed here, ls dark, ls light, pause, for each of those, does the name of one of those tests match something that we've got in our list of tests that we got back from the POI list? And this is brilliant because that's all we're doing is seeing it's all already been conducted. It's all already been tested. What we have is a name of things that matched and their percentage value. And now all we have to do is check and see, well, in this list of things that I'm looking for right now, does it exist? And if it does, then we draw it, which is this code that sends it to the UI, but don't worry about that. And we log the event. And if we now have a match, we found a match, then we set our cycle to false, meaning now we're in the unmatched cycle. Now we're waiting until we don't see this anymore. So now that we're in the unmatched cycle, the next time we come through here, instead of if self.cycle, we'll go to the else, because this will be the unmatched cycle. Self.cycle will be false. And then we'll see, do we have a match from, you know, that was in the tests? Was there a match in there? And if there was, then we do the same thing that we just did up here, except for our unmatched test. Remember the one that, like, you can bail from one no match scenario directly into something else. You know, go check if you see the pause menu, because that's a thing. And then if you don't see the pause menu, then it's a proper unmatch. So that's what happens here. And what do we do when we find an unmatch event? Well, we log the event and we switch which test we're on so that, you know, we've dumped into the other test. And then in the event that we had a match and then we went into the unmatched cycle, but we didn't find a pattern specifically to unmatch to, then we're into that no match scenario. the no match thing. We're in run select. Once we're, if we don't match with anything coming out of run select, and that means we started running, so we switch over to running, and at the same time we fire off the no match action of start the run. Then we're in a no match state, and that is right here. We draw it, we log the event, we set our cycle back to searching because we've just no matched, and we switch our pack over to whatever pack it told us to go to here under no match. So we were in run select, we want to switch over to running, we want to log that it's a start action. That's all that happens, that's the analysis. But it's so kind of convoluted in the whole, it's a match, that you're in this, which cycle am I in, and then which thing should I do, that it was hard for me to wrap my head around what needed to happen here. And I think I had to, in order to get there, I had to reimagine what kind of information I was storing, and then it was easy. I was already doing it this way, but I just couldn't make it mesh with the new system for a long time. And then I did. Charlene! Charlene! That sounds right. That's plausible. I could believe that. How much do you want for it? I'll take it off your hands. What do you... I mean, I don't know. I don't know. Maybe if you took $5 off the price, I could start to consider it. I think it was Charlene. How the hell did I come up with the name Charlene from? And then this is the main thing that gets called whenever we go to process a video. It does a basic reset to put a bunch of variables back in their original state. We start up a timer that's just there so that we can have, information about how long did it take. And then this is probably unnecessary, but I'm doing it right now. So, I'll take it out if it becomes unnecessary. We actually open our own video channel to the video, even though all the multiprocessing is going to do that in a minute, because this is what calls the multiprocessing right here, and we haven't gotten to that line yet. It opens it up, and it asks it, what's the frame rate, frames per second, so the capture property frames per second, and it asks it, how many frames have you got fully in there? And then we just close it back up because we're done with it. We don't even read in a file. We just access the file, ask it how many frames per second, what's your frame count, and then we're going to use those values down here to figure out what our end and start values should be, or how much the total frames are. We're going to reset the end, we're going to set the total frames. Start has already been passed in. It's either 0, very beginning, or it's been moved by our mark in, mark out points in the UI. So we set up our start and end, and with start and end, we can now initiate our call to the multiprocess function. So POI list is equal to the MP tests, hand across the vid path, file path, start and end, and boom, that starts off the multi-core processing, which locks up Python and the UI, and it just sits there and does nothing until it's done, and it'll probably lock up the live stream too. When we do it, and we're about to do it, and then that gets done, we come back from that, and I have to actually initialize the packs on our clustertruck.rp file here, because this is, all of the clustertruck.rp files that we were working with in the multi-core processing, those all existed exclusively in those pipes, and now they don't exist anymore. So in order for us to do the analysis, I have to get another one up and running, initialize the packs, put them into the right state, and then we can start the analysis. We do the analysis that we just looked at, all this stuff, and then we just generate the output. It takes no time whatsoever to do everything after the multi-core processing test. It is a difference of like 1/10 of a second, and it's all done. It's fucking incredible. And then this is stuff just shoving it out to UI and printing some more stuff and, logging how long it took. That's the whole thing now. Who wants to probably crash? I don't think the computer's going to go down. I don't think the live stream's going to go down. I think everything just might lock up, though. And that's why we've got the CPU. In fact, I'm going to pop this open. Okay, we're going to pull up the CPUs. And I'm going to start up the... Nope, that's the wrong thing. I'm going to start this up. Don't burn things. Why do you need to glitch lit? That's no panic basket. Thank you very much. I'm going to have this up. We're going to watch the CPU utilization. If these stop moving, if you stop hearing my voice, then it's because 12 cores have just hit 100% and they don't have any time to tell you what's going on. 720 test video. This is a video that we've been using to test this program. Remember that like this program is set up so that I can do mark in, mark out points. I could set it up to the frame I want to start at, the frame I want to end on. We're not going to play with any of that. We're going to do it from the very beginning to the very end. And I'm going to hit the analyze button. And here it is. Quit with the F's in chat for Charlene. In 3, 2, 1. Video analysis has started. You can see all of the 100% maxing out. I don't know if you can still hear me or see me, but we are now at 100%. Oh, and we're done. And we're done. Welcome back to the stream, in case I lost you there. Switch to the phone so we can watch the meltdown. That was, we just processed a 2 minute and some second, how long? It's 2 minute, 7 second video. And we're back. Did I freeze up? Did I freeze up? You can see up there the CPU completely pegging out. And look at the memory. Look at the memory usage. That's how little it took to process this. And it doesn't fill up that much more, like it gets to a certain level and then it just holds there because you're only ever analyzing one file at a time in each thread of the multi-core process. Damn, that's quick. Isn't it though? In fact, here's how quick it is. Video analysis of 3,819 frames in 720 test.mp4 at 30.01 frames per second complete. Analysis took 9.5 seconds of the duration. This is the total video, or the total frame length that we looked across. 2 minutes, 7 seconds of video. We did it in 9.5 seconds. And the only reason that it took 9.5 is because I'm live streaming right now. It usually takes 8.2 to 8.4 seconds. We did freeze up? Cool. Cool. Yeah. So the other thing that I've done now in cleaning up my code and ripping out a bunch of logging stuff is I've also made it clean and pretty to look at. So at the top of this list, it also lists what we were just looking at in terms of how many frames it's going to process, what the video file is, and what the frame rate is. The POI list contains 140 frame events, so this generates immediately after we get done with the multi-core processing, and it tells us that the multi-core processing took 9.538 seconds. Then we print the run log, which is sort of the raw, unprocessed data about the run, where it tells us each event and the splits between each event, and what frames they happened on, and so here you can actually track. Limit it to max core 1 and run it again. If there's not a problem with that, maybe I will. That could be fun. That could be fun. But you can actually track what, how SplitRP works here. It starts out and it's looking for run select. It's looking for that level select screen. And it finds it, and it doesn't do shit when it finds it. It hasn't been told to do anything when it finds it, but when it unfinds it, then it starts. So we got a 0.0% match. It unfound it. It couldn't find any run select anymore. It couldn't find anything else that it might have transferred to. So it starts the run. And then we go into this loop because we're just, we're actually speed running now, where we're in running and we're looking for the level complete screens. And when we find one with a match of 98.5%, we pause and split. So we fire a split off and we pause timing for the sake of IGT. And then when we when we fall out of running, we have a 0% match in running, we unpause timing so that we're timing it again for the sake of IGT. So that's the run log, and you can follow that along and see what it was doing and how it was doing it. And then when you get down to the splits, I print out a nice, cleanly legible table of all of the splits and what they were. Over here we have the splits as they add up. So we've got like total, I think this is RTA time I'm displaying there, and total frames as they're adding up. But here we're showing each individual level. So on World 1, the RTA was 8.564, 257 frames. Same for IGT because it's World 1. We've just started the run. There's no place to lose time. By the time we get to World 2, the RTA for that is 12.829, and the IGT is 12.529 with a waste of 0.3 of a second. That is level load time. That is the time spent on the level complete screen, and that's how we get IGT in Cluster Truck. So it gives you a nice list of all of the splits, and then also at the bottom gives you the split totals, telling you that by RTA, the entire run was 3,647 frames long, which at 30.01 frames per second is 2 minutes, 1.526 seconds. And by IGT, it was 3,517 frames long, which at 30.01 frames per second is 1 minute, 57.194 seconds. And that means that there was a total waste in this 2-minute run, less than 2, I mean, about a 2-minute run between RTA and IGT of 4.3 seconds, which is actually very good. But that is also the reason why IGT and why SplitRP was such a necessary thing here. We wanted, IGT timing for our leaderboards, because if you've got a slower computer, or if, like me, you usually run while you're live streaming, that means that there's frames lost to how long it takes to load the next level in. This is a run being, just locally recorded by Wolfie. Well, he was running a long time ago. He loses 4.3 seconds across World 1. And that's just 10 levels. So multiply that by 9, because there's 90 levels in there. And we've got a lot of time lost. And that's actually a pretty quick one right there. If you multiply that by 9, that's a hell of a good run in terms of not having that much waste. But some runners routinely see over a full minute of time lost to the level complete screens on a full game run. And that just makes it unfair and uncompetitive for people who don't have the best equipment. So thanks to SplitRP and thanks to the work of the moderators doing some of the IGT calculations by hand, and thanks to the live split integrated auto splitter that records timing based on memory events in Cluster Truck, we can now have IGT, and we now have a more competitive and a more fair leaderboard than we ever would have before. Limit it to max core 1 and run it again. I like this idea. Let's see if there's a reason that I can't, or, if there's any reason I can't. Incidentally, in the UI, all of that information that's printed out in the console is, it's here as well. It's here represented as well. Very ugly, just basic implementation to make it so that I have made compiled versions of this. Compiled versions that people could run without having to run it through Python, and sent it to, moderators and had other people test it. And I just wanted them to have access to this data without, crawling through a console window. So, max -1. Oh, you want to do max core -1 run again? You want 11 cores? All right. So I have to do that in 2 places then. At least 2 places. Number 1 I think in the POI test. I don't have it here. I do have it here. Total workers equals multiproc CPU count. So basically wherever I see this, let's do a replace. And let's do CPU count -1. -1. So replace you. Replace you. That's it. That's all the matches. Okay, so 2 places where I had to do that. So -1. We want to try it again? Pop it open. Let's get that up. Get you over here. File, open. 720 test. And we'll do the analysis. In my naive thinking, couldn't you skip end frames after an unpause as an optimization, as it's very unlikely you'll run into another pause screen after 150 frames? Yeah, but I could set that up as a characteristic that you could set, I suppose, when you're writing a configuration file. But it's definitely something that would have to be configurable like everything else in SplitRP, because this isn't just designed for Cluster Truck. This is designed for anybody and everybody's leaderboard who can make use of it in their speed run. And we have a level in Cluster Truck where you turn around and jump out. You can get that done in about 1.3 seconds. So you can skip some frames, but I mean, in a 30 frame per second file, about 30 is already too close. It's too many. It's too tight. And the other thing is that probably wouldn't help. Skipping frames is the big overhead that we're up against here is like all my testing happens faster than anything can actually happen in here because of the bottleneck of loading to the next frame in the video. So even if I told it don't do any testing and just skip the next 150, I've still got to move the read head forward, and that is what takes longer than anything else that's going on here. My actual tests that are being conducted, my intensive operations, they happen in a non-observable amount of time. You can't tell the computer to note what time it is before you start the operation, then do one of them, and then check again and see that there was any difference. But let's try this with 11 CPUs instead of 12 and see what happens. In 3, 2, 1, go. And we've got... Which CPU didn't get used? Which CPU didn't get used? All of them are being used. That doesn't seem to have... Didn't actually work, is what. It doesn't look like it actually worked. Stop motion time. All of the CPUs hit to 100%, so changing that didn't quite work out. So multiproc CPU count, and that is in the POI test where we define the total workers. -1. I don't know, but you know what I'd like to try? I would like to try, if I set total workers to, well, to 0, actually. Maybe to 1. It depends on how the range thing operates. It stops on the top. Yeah, I think it does. So if I set total workers to 1, try 50% cores. I'm going to try it just at 1 and see if this works. So I set it manually to 1 there. Do we have something down here at the very bottom of everything where I identify that first before I send it through? No, it's all just up there. Okay, let's just try 1 worker and see what happens. So restart the program, get you over here, make room for all these, file, open, 720 test, analyze. Okay, so we're going now. One of these workers is supposed to be working. I don't see which one it is. I think it's just being... Is it being, like, farmed out to kind of everybody in order to cover the demand? Like, both of those are kind of spiky. I mean, everything's kind of spiky, so it's kind of being threaded across all of the processors there. Is what it looks like. But that took 18.34 seconds with what I believe would be just 1 core operating, because if it's 1, then the range of 1 should just be 0. I think that's how that works with Python's range feature. When you say range 1, you just get 0. It doesn't go up to 1. It stops there. I didn't get a Discord or Twitch notification. I wondered, because it took a while for people to show up here. I wondered if things didn't go out right for some damn reason. So that's 1. You want to do half, though? Let's try doing half and see what happens here. But it's definitely like trying to load it all out between as many CPUs and balance the load. So that took 18.3 seconds. Okay, bear that in mind. Let's set the total workers to 6. I got 12 on the system. Find me... Oh, shoot. Well, where's the... It's there. Okay. In fact, we'll do divide by 2, because then I'll still have the value there that I can search for to be able to change it around and stuff. Y'all ready for this? So we'll divide by 2. It should be 6 now. We'll start her back up. We'll put you over here. Bang, bang. File open. 720 test. Full analysis in 3, 2, 1, go. It didn't. Float object cannot be interpreted as an integer. God damn it. We can do that kind of division, which should floor it, I think. Give me you. Back over here. File open. 720 test. Pull that up. And in 3, 2, 1, go! And I'm seeing, you know, full maxed out on all of the cores, even when we were told just to use 6 of them. And analysis took 9.3 seconds. So yeah. Yeah. I don't know, on a multi-core system, apparently with Python, even though I've got 12 virtualized threads, 12 is equal to 6. I think it's doing exactly the same thing. It's doing exactly the same thing. It seems to be getting about the same amount of time out of it by trying it. Stream's lagging a bit. You think so? I'm cracking out 100% on my CPU. Well, we're doing this. Shall we do divide by 4 and floor? Should be down to 3 cores if we do it like that. We're just having fun now. We're just tinkering, aren't we? So get you open, put you over here, pull this back up, and I'm going to keep moving my hand. In 3, 2, 1, go. Okay, scanning again. And okay, things aren't completely peaking, you know? It's definitely sharing the load across all of the cores, but it's not peaking everything to maximum height there. And the duration that it took on this one was 11.0 seconds. So yeah, it's looking like when I have 6 cores or higher, I get the same results as if I've got 12 cores running. Which is curious. Curious to note about this. It's not as bad as it was before in terms of stream lag. Oh, really? With the half of them going? I still, like it. I mean, we're gonna use every core we've got. Obviously, we've got them here. We're gonna use them, and I want to do that again. And you can see the stream go to shit for a minute. Huh? No lag this time. Oh, no lag? Cool. Oh, Jesus, that's a lot. It's not as bad as it was before in terms of streaming. No lag this time? No lag? Wow, okay. Let's try with all of it again. Because it's just fun, isn't it? So, here's the one where we're going to stop and tell me if does my voice cut out while this goes on too? In 3, 2, 1, I am the Ronin Pawn and we are scanning with this file. It's a Python. It's a code that we are looking at and it is running. It takes 8 seconds long, actually 9 while we're doing this. And I'm back and the CPU is coming back. Can you see me? When can you see me? Can you hear me? Can you hear me? Only the video stops. Oh, okay, cool. Then I can sing continuously for everything. Interestingly, and it's probably just variability because there's so much going on while the stream is going. But interestingly, when we run the 12 cores, we're using the virtualized cores. This is 9.5. When I was doing half the core count, it gave us 9.3. So I wonder if I'd be better off with half the core count. But that's a thing where it's start fucking with that, and then it's well, on AMD systems, because of the way they do the multiprocessing, but if you've got dedicated cores specifically, and then you cut it in 2, then that'll be, and it's just leave it, let it have everything. Video stopped for roughly 3 seconds. 3 of the 9.5 it claims to have taken to process this 2-minute file. I'll tell you what we could do. That would probably, you said that there was no lag when we were doing it in quarters. So if we did divided by and we do it in quarters again. Wait, no, I was doing it by 3, right? Yeah. Because then we got 12, and so that'll be, do it by 3. Okay, so if we do like that, then I can probably process a larger file and show you what that does, too. In fact, what I'd like to do, and you guys can tell me how well that this hangs together, but let's go to downloads. And now I've got I think this is a 720, 60 frame per second run right there. It's about a half hour long. Let's pull that one in. Oh, no. This is 726. This is the wrong one. Yeah, I don't want to do that one. I want to do one that's longer. We'll do, go over to downloads, because I'm a moderator, so I've got your speed run. We'll do, I think this is Noah's run. So we'll process this. In fact, we'll process it as though we were actually going to process it. I will take this back to the end of 9.9 when we move into 9.10. So there's 9.10. Okay, we're in 9.10 there, and then at the beginning of the run, we should be fine to just start at the beginning of the run. So this should run on some amount of processors. It's divided by 3, so it should be 4 processors, but, you know, it's going to share the load across all that. Let's see if this one actually holds together. So we analyze. This is not as fast as it can possibly go because, you know, reasons and things and stuff. Right now it's saying that we are consuming 100% of the CPU. Can you see me? Can you hear me? This is, maybe I do need to do it in fourths then, because I was hoping that we'd still have a little bit of CPU left over to process video and whatnot, and right now it's looking like not so much. I have dropped frames 446, so this is the first stream in quite a while where I've actually got dropped frames showing, and I'm doing it intentionally to myself. Pause a little when you started, but good so far. It's still fine. We can see and hear you. Little bit of lag, says like guy 89. Yeah, we're not dropping frames anyway in the encoding there. So 100%, but I guess it's leaving enough resources for OBS to, you know, take them as well. What it means. Stream normal. Cool. Cool. So this is a half hour's worth of video that we're processing, and I believe this is at 720p, 60 frames per second. You saw when I started it up, and we're doing it with slightly hobbled resources because we're not using all 12 of the cores. We're not even using the 6 cores that apparently operate the same on this AMD platform as the 12, at least through Python's multiprocessing. We're using 4 cores, which is 100% of the CPU as far as Windows Task Manager is concerned, is what's being used right now, but it's not all dedicated to the processing, is it? The processing window, the file window, is just going to hang because I haven't done anything about that yet. Might not. I'm going to look into multi-threading the user interface separately from the rest of the program, which is how, you know, a UI is supposed to be done. But even then, I don't know. We saw that updating the UI was a big load on the program. You know, when we turned the UI off after I'd done some of my updates for the testing, but not multiprocessing, after I'd patched out some of the testing to faster versions, turned the UI off, and we went from 22 seconds to process that 2-minute video file that we usually process down to 14. And it was just by turning off the UI. So, but when a UI is properly multi-threaded and it's not being forced to update frames, not being told to update frames, and it's just updating when something happens, then, you know, it won't get in the way. But you'll still be able to, like, click on the window, drag it around, interact with things in it, and it will take some of the CPU away when you do. But, yeah. So again, half hour worth of video being processed right now at a slightly hobbled version of this program, and I expect it to be done pretty fucking quick here, honestly. Like, sooner or later, you know, we're delayed by the live split, we're delayed by there's less CPUs working on it, but in testing, I believe this half-hour video took...
There were funky Chinamen from funky Chinatown. They were chopping them up, they were chopping them down. It's an ancient Chinese art and everybody knew their part. From a feint into a slip and a kicking from the hip.
And the man in the back said everyone attacking it turned into a ballroom blitz. Thank you, Little Magnets, for the 100-bit cheer. Oh, is that what it is? Okay.
Everybody was kung fu fighting her. Those cats were fast as lightning, ha. In fact, it was a little bit frightening, huh? But they did it with expert timing, ha.
Ha. Thank you for the kung fu fighting. That I thought was the man in the back said arrow on attack and it turned into a ballroom blitz. And the girl in the corner said, boy, I want you to turn into a ballroom blitz, ballroom blitz, ballroom blitz. So there it is. She's complete. Did she do it right? Let's see. Do we have the right number of splits? We have 89 total splits. That is the correct number of splits that we expect to see across a full game run. 89, we can't split the 90th one. There's no visual way to detect it, so that's what I expect to see. Those numbers look plausible. 2808 and 2723. Sure. I don't fucking know. But, coming into the level before the last level, anyway. And importantly, the analysis took, you could see it's right above me. Just look, see that hair on the cowlick? Look where my cowlick would be. Analysis took 3 minutes 38.582 seconds in order to process a 2828 file, and that is on 1/3 of the cores that we have available while doing a live stream. 3.5 minutes, more or less, for 28 minutes worth of video. Welcome to Pawn Radio. You are listening to the only something in Something Town, where the exclusive contracts. That is SplitRP. That is the new SplitRP. It's we can go back over here while I'm just cleaning up here, but that's it. Like, I don't know what else I could show you that's in the code, it's boring for you. It's very entertaining for me to go, and look what I did with the logging. Oh my God, I made the logging look so good, everybody. But this is it. Incidentally, this version of the splitrp.py file, down to 411 frames. 411 frames total. This was well over 500 frames before I started, optimizing it and pulling it out. We've added a feature, and we've got 100 less lines of code in here, and it's running 3 times faster. And it's exporting what are very, very pretty. Fucking goddamn, you just grab. No. Why do you always grab that? Huh? I'm gonna grab you. Throw you across the goddamn there. Just fucking, come on now. It's there. Hover it. No, the fucking, there you go. Jesus Christ, Windows. But yeah, very, very pretty splits readings here. Look at that. Look at how that layout is. I even got it all formatted and stuff. And then up here, you get the whole run log there. The information that you need, only the information that you need. Maybe kind of half, almost, sort of want. I'll tell you what. Okay, there's one more thing. One more thing we could do here. Just pull you back down. And then pull you back down. One more thing that we could do is if I go into the if I go into the POI test, okay, and I uncomment this stuff, we can get an output of how many of the tests are being saved. How many of these difference tests aren't needing to be done because we do this much faster sum test version first. We can get a printout of that from each worker as they do them. So this will, definitely make the live stream stop and stutter when we do this, because I've got all of the cores enabled again. But we're going to do 720 test rate there, and I'm going to hit the analysis. Boom. And we're going. And we're going, and we're going, and we're going, 100% CPU, and we're going, and it's done, and the test is complete, and it looked right, and it looked correct, and God, have I fucking done it again? Have I fucking done it again? Fucking God. Damn it, you can't grab the fucking thing if you fucking drag it down that fucking far. Pull it back up. I'm going to do a bit of this, give you some more room to look at things there. So, each of the workers reported right here. Worker number 0 stored 22 frame events. It dismissed 6,807 of 8,112 tests, which is 83.91% of the tests that it would have done absdiff style, which is the long, boring test, with some testing. We are dismissing on average probably like 80, something like that. high 80% of the tests are being thrown away by a testing version that is 2 times faster at the minimum, and that can be in the clustercheck.rp file 15 times faster using that method. Pretty fucking cool. Next time, make a weird face when you hit the analysis button so that I get... No, thank you. You can get your own smudge frames. But yeah. Yeah. And look at this. Here's another thing to note, is that the multiprocessing work was done in 9.808 seconds, and then the rest of it was done in 9.826 seconds. So 0.02 of a second later, we had finished the analysis of what the multiprocessing gave us back in order to generate this splits file. Do I seem chuffed? I think I'm chuffed is what I am. I feel very chuffy right now, and bloated. Chuffy and bloated. Chuffed a bit and retaining water. Those are the 2 feelings that I have currently. That's brilliant. I'm insane. I'm awesome. I can't believe I figured out multiprocessing too, because I've tried many times before to crack that nut and figure out exactly what it was that I wanted and needed, what I needed to do in order to make the damn thing happen, and just hadn't gotten it. Never quite figured out how to get into it. It's one of those things that people who write about it on the internet are coming from a place where they already understand it, and they apparently can't go back from that and explain to someone. They can't remember what it was like before they understood it to just explain what needed to be done, because, as I say, that's really all the code that was necessary. That and the fundamental concept of keep it simple, stupid, of write linear code that doesn't bring objects in from outside of it, because it's going to be in a big... Just think of each pipe. Think of each processor that you're going to run this on as a big, thick pipe. Nothing gets in, nothing gets out, and write like that. Instead of trying to slip things in from elsewhere. No, if you need an object in there, spawn it from within it, if you can at all, and then you don't have to worry about it. Then you just need a couple of lines of code to get multiprocessing up and working. It's no big deal. It's not a big deal. It's a slight deal is what it is. It's barely sort of kind of half of a deal is what I'm saying. What did this look like? All right. Jesus. I keep wanting to go to and I'm going to hit the analysis. Let's see what this looks like. Okay, well, you guys
and we're
can't
going.
see this.
And we're going. And we're going. Do-do-do-do. And we're going. 100% CPU. And we're going. And it's done. And the test is complete. And it looked right. And I'm going to hit the analysis. Boom.
Hit the button. And
we're going.
now he's stuck.
And we're going.
He's definitely
And
stuck.
we're going.
That's a stuck man.
Do-do-do-do. And we're going. 100% CPU. And we're going. And it's done. And the test is complete. And it looked right. And it
All right, so now we're to the point where it's like, hey, guys, I know this was a short live stream, but like that's all I really wanted to do was come and share with you my Python success. Feeling good about, hey, I made the multiprocessing work and showing it off working. At this point in the code, there's things to be done. There's a lot of things to be done. I ripped out like the image saving functionality of the code in order to just get it out of my way so I didn't have to worry about it, and that worked out very well. And now what I can do is for every edge of the code where we do an action, I can just like go to that edge and pull that image directly from, like reopen the video file, go and collect them and draw them after the fact and load them up without, where it's non-time dependent, non-critical process kind of a thing. So yeah, there's lots of little things to be done on the program, but like this is a major accomplishment and it is available. Jesus Christ, I keep having to hit the 8 button over there, bring it back over here, because it is available today if you want to look at the code, if you want to download the code, if you want to play with it yourself. It's not compiled, it's not ready to run an executable, but it is Python code that you could run here at ronanpawn/SplitRP, and then underneath the video moderation tool branch that is brand new as of today. You can go and get the code from there if you want to play with it. So available to everyone in homes Allow 6 to 8 weeks for shipping and all that sort of a thing. But I think that's it for this live stream then, you know? I just wanted to come and show the Python thing off. And then when we come back, next live stream, I think it's probably that. Probably we're gonna do this, and we're gonna set up another one of those things. Oh Jesus, I didn't load up stream labels, so nothing's been updating because I'm a damn fool. Now I'll open it up at the end of the live stream because that makes so much sense. Just to show you how, despite the subscriptions that came in today, we lost 3 subs since the last subscription. It's the last live stream. So yeah, next live stream, I think we'll hit up Cluster Truck Twitch %. I don't want to get too far away from the no ability speed run. We're on the verge of getting second by over a minute. You know, taking a minute off of second place or something like that. Maybe 40 seconds off of second place. So I want to get that before I get too rusty, but yeah, I think from here on out, I will keep the Python streams to a minimum or a nonimum, unless, you know, you demand it, and get back to doing some speed running here. Okay? Thanks for coming out. I hope you enjoyed the multiprocessing Python breakdown, where it was just me kind of going, look at what I did. Join me at the next live stream where I'll be speed running and asking you to look at what I'm doing. Kind of selfish. The bane of the entertainer. Thanks for coming out, everybody. I will see you at the next stream. That's a pawn out.